Hello friends, welcome to Brain Amplifier, and today we'll learn about the insulation resistance and polarization index test and where these tests are used. See, both insulation resistance test, that is IR value test, and PI value test, that is polarization index test, are conducted on high voltage machines to determine service condition of the insulation. See, in the large machines we have huge size of rotors, that is in power plants we have huge size of rotor, and we cannot see the windings of the rotor physically, so we have to check whether the winding has some contamination or some moisture content. So I have to do some tests, and those tests those things are done by insulation resistance test and polarization index test. IP test is conducted specially to determine the dryness and cleanliness of winding insulation. So in insulation resistance test, that is IR value test, a high voltage a high DC voltage is applied across conductor and ground. That is, see, if this is my conductor, this is my insulation, I will apply some voltage across this insulation, because I have to find out the resistance of this insulation. I'll put one cord of my DC supply to the conductor and other to the outer area of the insulation. So as R is equals to V by I am supplying some voltage, and I will find out the value of current, and that will give me the value of resistance. And these values are calculated by using the measure that gives in the value in the mega ohm. Okay, so the instrument which we are using to calculate the value of insulation resistance, that is measure. But we see one problem, and that problem is the value of the reading in measure changes with time. So the reading changes with time. So what is the problem? Why the value why the reading is changing? So here comes the logic. See, the current that we are supplying has four components, that is capacitive component, resistive component, surface leakage component, and polarization component. Okay, that is, if we will talk about the capacitive component, see, when a DC voltage is applied across this insulator, as this is a dielectric nature material, so it will polarize and it will act as a capacitor, so it will take some charging current. Okay, and generally this current exists for initial 10 seconds of the test, but it takes nearly 60 seconds to decay totally. So see, if I have this total current equals to my capacitive current, okay, and my resistive current, and my leakage current, and my polarization current. So this capacitive current will decay, that will completely decay only after 60 seconds. So up to the 60 seconds I'll be having IC component in this current value, and that will increase the total value of current, and that will reduce the value of resistance. So after 60 seconds my value of resistance will change. I mean, slowly this value of resistance will change. Okay, second thing, okay, resistive component. What is the resistive component? I am applying a voltage, it is giving me some value of current, and the net resistance, the purely conductive in nature, flows through the insulation as if the insulator is purely resistive. So this is direct flow of electrons. Okay, that is giving me the resistive component. The third component is surface leakage component. Why this occurs? Because I may be having some dust materials or contamination on the outer surface of the insulation, or so because of that there may be some leakage component of the current. The fourth part comes the polarization component. What is the polarization? See, in the I may be having some moisture part in the insulation, and for your kind information, the insulations are hygroscopic. That is, they love the water, they want to take as much water as you can. Okay, so due to their hygroscopic nature, they may be having some moisture content, and if I apply some voltage across this moisture content, the moisture will polarize. Okay, so every insulator is hygroscopic in nature. Some contamination molecules and mainly moisture in the insulator are very polar. Okay, and when an electric field is applied across the insulator, the polar molecules align themselves along the direction of the, suppose this is my electric field, and there is some polar material in that electric field that will try to align itself in that field. Okay, So the energy required for this alignment of polar molecules comes from voltage source in form of electric current. So I have to supply some extra current for this alignation. Okay, so this current is called polarization current, and it continues until the polar molecules align themselves along the direction of electric field. And it takes, how much time it takes? It takes about 10 minutes to align the polar molecules along the electric field. That is why if you take Mager result for 10 minutes, there will be no effect of polarization in Mager result. So up to the 10 minutes, I will be having some IP component, okay, in this total current, and that will increase the value of total current and reduce the value of R. So I'll be having the exact value of the insulation resistance only after 10 minutes. Up to 10 minutes the value will be changing, because I am giving some extra energy, one to provide the charging current for the capacitive thing, and the second to align the molecules. So if there will be more moisture, there will be more alignation, there will be more current fed to that, and there will be less resistance. Okay, now see the mathematically, if we will see polarization index, what it is. See, initially the resistance value will be V upon IR plus I leakage plus IP. That is I polarity, resistive and leakage. I am talking about after 60 seconds when capacitive component has gone. And if we take the Mager value after 10 minutes, this is uh, after 1 minute. 1 minute. Okay, and if we take the value of after 10 minutes, that will be R equals to V up given 1, and that is 10 V upon IR plus IS. So the result of polarization index, so mathematically, what is polarization index? That is R1 divided by sorry, R10 divided by R1. That is the value I am taking after 10 minutes, and the value I am taking after 1 minute. The ratio of these is called the polarization index. So ideally, if my insulation is good, the value of R10 should be at least 2 times the value of R1. That is my that is after 10 minutes my resistance should be doubled. Okay, you're getting my point? Should be 2 or more according to IEEE. So from the above equation, it is clear that if the value of IR plus IS is much greater than IP, the PI of insulation approaches to 1. Okay. So the large IR or IS of both indicate unhealthiness of the insulation. Now, it is always desired to have a polarization index of electric insulator more than 2, and it is hazardous to have polarization index less than 1.5. So this is all about the insulation resistance and polarization index test. Thank you so much.